Let's solve the tutorial sheet on uniform accelerated motion and the projectiles. Without wasting much of the time, let's start with the first one, which says the velocity time graph of a runner is shown in the figure below. How far does the runner go in 16 seconds? Then number 2 says what is the acceleration of the runner at t is equals to 2 seconds and at t is equals to 11 seconds. Then the goodness with tutorial sheets for physics is that the answers are already given. So let's start with the first expression. So we are being told that we are supposed to find how far the runner goes in 16 seconds. Now, what do we mean when we say how far? How far is what? It's distance, right? Yes. So how far is distance? So we're trying to find the distance the runner, in terms of running, he runs like the whole race. So we're able to see that this runner runs until he reaches to this point. Okay, that is, it means he was accelerating at that point. Then he moves at constant velocity, then again he goes down, or he decelerates, then again he continues to move at this constant acceleration for some time. Okay, so we have to calculate the entire distance for that. So now we've got a lot of shapes here that we can create. So the first shape that we can create is this. Now this is a triangle, right? Then another shape that we can create is from there to there to there. Okay, then another shape that we can create is a trapezium from here to there. Then the last one that we are going to have, it is this. Then we find, the distance or the formulas for all these shapes. So we have a triangle, we have a rectangle, we have a trapezium, and we have a square. So let's just find those. So how do you find the area of a triangle? Okay, so the distance will be how do you find the distance? How do you find the area of a triangle? We say it's half base height. Okay, plus, then we said we have a rectangle, or let me say a rectangle is, so it will be the length multiplied by the breadth. Okay, plus, then we have a trapezium. So a trapezium is half that is L plus B, then there is H. Okay, the height, plus we have a square at the end, so that will just be L squared. So let's now find this. So half, our base for this triangle is from 0 to, you know that this is 2, right? Okay, so multiplied by 2 multiplied by, what is our height? Our height is 8, plus we've got now our rectangle. The length for this rectangle is, this is 2 and you're ending here, this is 10. So 10 minus 2, that is just an 8. Okay, so 8, our 8 is multiplying by, what is the breadth? From here to there, that is 8. Okay, so this is 8 plus, we've got a half our trapezium, so we've got a distance from what would be our length? The length, let's say it's from here to there. Okay, so that is 4, plus the breadth. So the one that I'd put like that, this would be like something like the breadth, okay, which we indicated as 4. Then the length from here to there, that is 8, plus the height from here to here, okay, that is 10. The height for this guy, what is it going to be? That is like from there to there, that is, if this is 10, that is like 2, okay. So well, the height of 2 plus our L squared, L, the length of this rectangle is what? From 12 to 16, that is 4, right? So 4 squared. Even this other side from here to here, you're able to see that it is 4. That's why I've said 4 squared. Now you have to punch this on a calculator and find that. So the 2 and the 2 can go. I'll just remain with 8 here, plus 8 multiplied by 8, that is a 64, plus what am I going to have here? So the 2 and the 2 can cancel. 4 plus 8, that is a 12, okay, plus 4 squared, that is a 16. Now this is, everything is in meters. Then when you add, on my end I'm getting 100 meters. So that would be the total distance that would be covered in this expression. That is 100 that they found there. So that's how we find the distance, or how far the runner goes in 16 seconds. Then question B is, what is the acceleration of the runner at t is equals to 2 seconds? So we're trying to find the acceleration at t is equals to 2 seconds. Now you know that acceleration is equals to your velocity divided by your time, okay. Now we're trying to find the acceleration at 2 seconds, okay. So what do we do? So this is 2 seconds, okay, that is 2 seconds. Then what was the velocity at that point? Okay, so you're able to see that the velocity is 8 meters per second. So 8 meters per second divided by the time we're saying is 2 seconds, okay. Okay, so what are we going to have? 8 divided by 2, that is just 4. So this will be 4 meters per square seconds, or 4 meters second squared. So that is the answer there. That's why you're able to see a 4 here, okay. So now the last question is, and t at 11 seconds, t at 11 seconds, okay. So where is our 11 seconds? So if this is 8, this will be 10, right? So 11 might be somewhere there, close, like very close to that point. So how are we now going to do that? So to find, we have to find the slope, because this 11 is on a slope. So we have to find the acceleration around that slope, okay. So we've got 2 points, so we can pick 2 points, this point and that point. We want to find the gradient along this slope, okay. So this point, let me say this point that is here, this is 12,4. Then the other one that is on top, this is 10,8. 8. Okay, let's go. This is 1, this is 2. Okay, so how do you find the slope? The slope, we know that the slope will just give us the gradient, right? So the slope will be equals to what? It will be equals to y2 minus y1 over x2 minus x1. That will be the gradient. Okay, so now what do we do if we are going to name those ones as 1 and 2? If I say this is 1 and this is 2, so this will be our x1, this will be our y1, then this will be our x2, this will be our y2. So I'm going to say y2 is 8 minus y1 is 4 over x2 is 10 minus x1 is a 12. Then we solve 8 minus 4, that is a 4, over 10 minus 12, that is negative 2. Then a 4 divided by a negative 2, that will give us a negative 2. Now that will be the gradient at that point, and the gradient at that point just depicts your acceleration at that point. So your gradient is equals to acceleration, so therefore the acceleration will just be negative 2 meters per second squared, or square seconds. So what this means is that as this car is slowing down, it is decelerating. That's what the symbol is, a negative. Okay, it is decelerating. So that's how we find question 1. Okay, let's go to question number 2. Question number 2 is saying the speed of a nerve impulse in a human body is about 100 meters per seconds. Okay, if you accidentally stab your toe in the dark, estimate the time it takes the nerve impulse to travel to your brain. What would happen if the speed of the nerve impulse was much lower, say 1 meters per second? So we are given a speed, the speed of a nerve in a human body, we are saying is 100 meters per second. Now at night you just accidentally stab your toe, or stab your toe. Now I want to estimate the time this nerve impulse is going to travel to your brain. Let's say this is a person. Okay, now this person has accidentally stabbed their toe. Now we want to find the time it would take for that impulse to go until it reaches to the brain. Okay, so how are we going to do that? Now you know that speed is equals to distance over time. So how are we going to find time? You make time the subject. Time will just be equals to distance over speed. Okay, now the first question is estimate the time it takes the nerve impulse to travel to your brain. So what is the distance? So we'll assume 100 meters per second. Okay, we'll assume that this person is the distance. We can just choose maybe the normal height of a person. Let's say it's 7 meters, right? Okay, divided by the speed. The speed you are saying is 100 meters per square second. So you are going to divide that, and you are going to find that your time in that regard just be 0.07 seconds. So that is just an estimate, provided this person has a height or a distance of 7 meters. Okay, then the second question is what would happen if the speed of the nerve impulse was much lower, say 1 meters per second. So we're going to say time will just be equals to the same distance over speed. Now the distance in this case, we're saying it is what would happen if the speed of the nerve impulse was much slower? Let's say 1 meters per second. Okay, so 1 meter over the distance that we're talking about is 1 meters per second. What would happen if the speed was much slower? Let's say 1 meters per second. Okay, so we're talking about 1 second. Now this 1 second, in this case, the nerve impulse would take significantly lower to reach the brain, because it is taking time. 1 second, at least at this point, it was taking about 0.07 seconds. That is much faster. But now when you're talking about 1 second, it means that it will take longer for that impulse to reach to the brain, and the impact will be what? This person will be feeling even more pain, right? Because for him to be, for the best lower reaction time, okay, and potentially this can lead to maybe discomfort or even more pain. Okay, that's what you need to understand on this one. Then number 3 is a track traveling at 22.5 meters per second decelerates at 2.27 meters per square seconds. Okay, this track is traveling at, okay, so it's traveling at 22.5 meters per second. Then the acceleration is 22.27 meters per square seconds. The first question is how much time does it take for the track to stop? Okay, let's assume the track is going in this direction. Okay, or now since the track is decelerating, so let me draw it like that. The track is traveling at that and decelerates at that point. Okay, so if this is 22, then this thing decelerates. Okay, so if we're going to assume how much time does it take for the track to stop, so for this track to stop, what are we going to do? So we have to first find the time it takes for the track to stop. Okay, before we find how much time does it take for the track to, actually that's what we are finding. So you know that we say which equation are we going to use? V is equals to U plus AT, right? Yeah, we can use this one, it's still fine. So you know that your V in this case is 0, they haven't mentioned it, but the U you've been given is 22.5 plus A, our acceleration have also been given, which is 2.27, and we're finding the time. Okay, and we're finding the time. So we have negative 22.5 is equals to 2.27 t. So I'm going to divide by 2.27 on both sides. 2.27. Okay, so my t will just be equals to 22.5 divided by 2.27. Okay, 9.91 seconds, like that. So this will be the time. Now whether I put a negative, time is not in negative, so you just ignore the negative, and this will be the time it will take for the track to stop. Then question B is how far does it travel while stopping? How far? When we're talking about how far, we're talking about the distance, right? So what about the distance? Okay, how far does it travel while to find okay, so we're going to say the distance will just be equals to half ut, Okay, you remember s is equals to yes, s, which one is the best one? S is equals to ut plus ut plus half at squared. Okay, this one won't work. You can use which other one can you use? Okay, which other formula for distance can we use? I'm trying to look for a simpler one, because this is the one that has half. Okay, so 80 squared. There's other one too. It's equals to 2 is equals to squared minus 2as 2as. Yes, we're going to use this one. So how are we going to do that? We're saying this is 0, right? Is equals to u squared is equals to u minus 2s. Okay, 2as. Then if we're going to make what are we making? The distance is subject to the formula. Okay, what are we going to know? In this case we don't have time, so we're not going to use that one. V is equals to u plus at. Okay, so all these formulas won't work. So what are you going to do? Visualize what you're going to have. So you know that this track was moving. This track started at around like 22.5. So it was moving, it was traveling at this speed. Then it decelerated with a deceleration of 2.27. So now you're able to see that it will make something like a triangle. So now how are you going to find the area? Because this will be the distance, right? The area of this triangle will be the distance. So the area is half at. Okay, good. So half multiplied by, what is our u? Our u, or our initial velocity, it was traveling at 22.5 meters per second, times, what is the time? The time was just from finding, it was 9.91 seconds. Then you solve this. So on my end I'm getting 120 meters, so 112 meters. So that will be the distance this track will travel while stopping. Then question C is, how far does it travel during the 3rd second after the brakes are applied? How far does it travel during the 3rd second after the brakes are applied? So for us to do that, we have to first find how far it will travel in the second let me say in the second second. Then that's when we find how it's going to be found in the 3rd second. Okay, so how are we going to do that? How far does it travel? How far does it travel? Okay, so like I said, to find the distance traveled during the 3rd second after the brakes are applied, we need to calculate the velocity at the end of the 2nd second, and then use it to find the distance traveled during the 3rd second. Okay, so what are we going to do? We're going to say our velocity will be equals to what? U plus at. But now I'm able to see that this thing was decelerating, so minus at. Okay, so our u is 2.22.5 minus our acceleration. Our acceleration in this case, it was decelerating, that's why I put a negative. So it was decelerating at 2.27. this is multiplied by the time. Let's start with at 2 seconds first before we get to the third second. So 22.5 minus, when we solve this, okay, what are you going to get? Okay, so what are we going to get when we solve that? Okay, let me just solve all of it at the same time. So on my end, when I solve this, I'm getting 18.49 meters per second. So this will be the velocity at 2 seconds. What about at the third second? So if at 2 seconds is 18.49, so I'm just going to multiply this by 1 second. Okay, it will still give me the same answer, but now in this case, since we're finding the distance, it will be 18.49 meters. Okay, because you remember that distance is equals to speed. We say speed is equals to distance over time. So distance will be equals to speed times time. The speed we found that it was 18.49 meters per second. This will multiply by the time. The time that we want, we've already done for 2 seconds. Now we just have to do for 1 second, and we're getting 18.49 meters. Okay, so that will be the answer, although here they found 16, but it's very close. Okay, so that's what we're going to do. Question number 4. Traumatic brain injury such as concussion or concussion results when the head undergoes a very large acceleration. Generally, an acceleration less than 800 meters per square seconds lasting for any length of time will not cause injury, whereas an acceleration greater than 1000 meters per square second lasting for 1 meter seconds will cause injury. Suppose a small child rolls off a bed that is 0.4 meters above the floor. If the floor is hardwood, the child's head is brought to rest in approximately 2 millimeters. If the floor is carpeted, this stopping distance is increased to about 1 centimeter. Calculate the magnitude and duration of the deceleration in both cases to determine the risk of injury. Then assume the child remains horizontal during the fall to the floor. Note that a more complicated fall could result in a head velocity greater or less than the speed you calculate. Okay, so what are we going to do? So to determine the risk, we need to first calculate the size and the duration of the deceleration in both cases. The cases that we have here, we have the one where there is carpeted on a floor that is carpeted, or on a floor that has a carpet. Then the other one is the one that has what? The floor that has wood. Okay, so the first question is calculate the magnitude and the duration of the deceleration in both cases to determine the injury. So let's calculate in both cases. So traumatic brain such as results when the head undergoes a very large general acceleration less than lasting for any length of course, whereas an acceleration greater than suppose a child rolls off a bed. Okay, let's say this is a bed. Okay, let me say this is a child. Okay, that's not how the child looks. Okay, pardon me. Okay, this child rolls off this bed. Okay, and the bed is 4 meters. Okay, let me say this is our bed. This bed is 4 meters, or 0.4, actually 0.4 meters above the floor. Let's say this is the floor. If the floor is hardwood, the child's head is brought to rest in approximately 2 millimeters, and if the floor is carpeted, the stopping distance is increased to about. Calculate the magnitude and duration of the acceleration in both cases. Okay, so let's just do that. So let's start with so the height will be already been given 0.4 meters. So let's start with the hardwood. So how are we going to solve for the hardwood? So the distance, because we're calculating the magnitude and duration of the duration in the okay. Let's first convert the distance for the wood. The distance for the wood been given 2 millimeters. Okay, 2 millimeters. So how are we going to do that? 2 millimeters. Are going to convert this one to meters. So we're going to divide by 1,000. Okay, so you divide by 1,000 and it will become 0.002 meters. Okay, that will be the distance. Then the distance for the carpet, will be what? We've been given 1 centimeters. This 1 centimeters, let's convert it to meters. Okay, you know that when converting centimeters to meters, the conversion unit, you're just dividing by 100, right? So this will give us a 0.01 meters. Okay, so now let's calculate now the magnitude and the duration of each of these ones. Okay, so what are we now going to do? What we are going, allow me to wrap this side. Okay, so what are we going to do? So you remember that we are saying we're trying to find calculate the velocity, to calculate the magnitude and the duration just before it just hits the floor. Okay, so acceleration is goes to what? There's which formula can we use here? I'm trying to think. If we say v squared is equals to u squared plus 2as, is this going to help us? Of course it's going to help us. So what we're going to do, because this child was falling, so the initial velocity was 0. Okay, so v squared in that regard will just be 2as. Then we're going to square on both sides to find the final velocity. So the final velocity will be the square root of 2. Now because it's falling under the influence of gravity, so 2gh. So the velocity will be the square root of 2 multiplied by 9.8 meters per square second. That's acceleration due to gravity. The height we've already been given 0.4 meters. Okay, then what are we going to have as our final velocity? So the final velocity, what are we going to have as our final velocity? Okay, that is 2.0 2.89 meters per square second. So that will be the velocity. Now if that is the velocity, we said for hardwood what was 0.02 meters. That's just a conversion unit. Then how do we now calculate now the deceleration now for hardwood? Okay, the deceleration for hardwood. So in the same formula, if we say v squared is equals to u squared plus 2as, and we know that our initial velocity was just 0 because they started from rest and fell. Okay, that's like free fall. Okay, this child. So this is 0. Now if we're going to find the distance, or let me say the acceleration, how are we going to solve? You're going to divide by 2s on both sides, right? So that you remain with your a. Okay, so therefore your acceleration in this case it's just going to be v squared over 2s, or distance, or 2d. Okay, so now what do you do? So how are we going to find the acceleration? We've already found the acceleration, we've already found the velocity. The final velocity is 2.89 meters per square second. Now this is squared over 2 multiplied by the distance. The distance we've already converted. It's 0. If you're calculating for hardwood, 0.002 meters. Okay, then you solve that and you find your answer. Okay, you solve that, you find your answer. Then for hardwood, so when I solve that on my end, what am I getting? Okay, what's happening to this calculator? Okay, so that's what you're going to do. Then for the carpeted wood, okay, the one that has a carpet, how are you now going to, for the one that has a carpet, how are you going to calculate? It's the same thing. The velocity we've already found, it is 2.8. So the deceleration now, or the acceleration in that regard, it will just be what? The same, v squared over 2d. The v squared is 2.8. This is squared 2.82. This is squared over 2 multiplied by the distance. For the carpeted wood, we found it was what? It was 0.01 meters. Okay, then when you calculate that, you also find your answer. Okay, you also find your answer. So now we found the decelerations for the two scenarios. Then what other question do we have? Calculate the magnitude and the duration, okay, in both cases. So we found the magnitude in both cases. When you solve that, you're going to find the answers. Then we haven't just found the duration, the time. Okay, so how do you find the time? You know that time, you know that speed is equal to distance over time. So time will just be equals to the distance, the speed over the acceleration. Okay, so what are we going to have? The speed we've already found. The final velocity is just 2.82 over the acceleration. The acceleration is what? The acceleration, the one that you're going to find as the acceleration is when you find the 2. Okay, so it means I need to find the acceleration for both. So for the hardwood, the acceleration, if you calculate that, the acceleration is 1993.1. then for the what's this, the carpeted one, if you calculate the acceleration, I'm finding 399.12 meters per square second. So these would be the accelerations. Okay, so if you're going to find the time, it depends with the acceleration that you're using. If you're using for the hardwood, you're going to put the acceleration for the hardwood here. Okay, and you calculate 2.82 divided by that number on my end. Okay, and yeah, you solve and you find the answer, something like that. Then also on the other side, it's the same thing. If you're going to find for the carpeted wood, you're going to divide by 399.999 to find the answer. Okay, so now these answers that you're going to get, let's say, okay, let's just calculate them. Let me not be lazy. Okay, so if we're going to divide, V is divided by the one for the carpet. So this one I'm getting 0.00707 and number is going. Okay, then the other one, this one, if I calculate this one, I'm getting if I calculate this one, I'm getting why is my calculator before me? What's there now? What are we going to do? Is it 7.07 meters per square second? Okay, so per second, so that is the time. Now you're able to see that both deceleration are significantly higher than the threshold of 1000 meters per second. This one they've given us, where is it? Acceleration less than 800 meters per square second. But the accelerations that we're getting something like 1900. The other one is 3000 or 399. Okay, so that one 1000 is significantly very high than close to even 800,000. So this will indicate like there's a higher risk for this person to be injured when they fall down. Okay, but the risk could be much higher in wood, okay, than the one for the carpet. Okay, so that's what you need to understand on this question. Then number 5 is a ball is thrown upward with an initial velocity of 15 meters per second and then falls and is caught by the person who threw it. Okay, so a ball is thrown. Let's say this is a person. Okay, this person throws a ball. Let me say it throws a ball, it goes up, and again it catches it again. So how high does the ball go? Okay, so initial velocity, they're saying an initial velocity of 15 meters per second. They've already given us the acceleration due to gravity. We know that it's 9.8 meters per square second. Then how high does the ball go? So which formula we're going to use? We've been given 9.8. Then have we been given the height? How high does the ball go? So we're trying to find the height actually. So we're going to use v squared is equals to u squared. Now this boy is thrown upward. Upward is against gravity, right? So I'm going to say negative 2gh. Okay, then I'll make h the subject of the formula. So in making h the subject of the formula, what do we have? Now you know that the final velocity is 0 at the maximum height is 0. So 0 squared is just 0. Okay, so I'm going to say what am I going to do? I can take this to the other side, so I'll have 2gh is equals to u squared. Then for me to remain with my height, I'm going to divide by 2g on both sides. Okay, so my height will just be u squared, which is 15 squared, divided by 2. Our acceleration due to gravity, we said, is 9.8 meters per square second. Then you solve this. So the height on my end, I'm getting 11.48 meters. So that will be the height. Then b is after 1.5 second. After 1.5 second, is the ball still going up, or after 1.5 second, is the ball still going up, or it is on its way down? Let's find out at 5 seconds. Let's find out at 5 seconds. So what do we do? So let's find the velocity at t is equals to 1.5 seconds, the one that they've given us. So what are we going to have? So v is equals to u minus at. Okay, why I've put minus, I've given the reason. Okay, so v in this case, okay, let's find the velocity at that point. So the u is 15 meters per square per second minus the acceleration is 9.8 meters per second multiplied by the time. The time they've specified is 1.5 seconds. Then you solve 15 minus 9.8 multiplied by 1.5 is 14.7. Then when you subtract the 2, I'm getting 0.3 meters per second. Now, since the velocity itself is positive, so the ball, what this means is that the ball is still going up. Okay, so the ball is going up. Then question C, how fast is it going? How fast is it going the instant before it is caught? How fast? When we're talking about how fast, what are we talking about? The velocity, right? Okay, let me also just wrap this. So what you should know is that the ball returns to the same height from which it was thrown. So the velocity just before it is caught will be the same velocity, but it will be in this opposite direction. You remember the velocity that they've given you, it was it has been thrown at 15 meters per second. So it is going up. So the same velocity that it has been thrown, it will come back with the same velocity, which is 15 meters per second. But now look at the direction. One is going up. If it chosen up to be positive, meaning the other one will be what? Negative. So the velocity at that point, or how fast it is going to how fast is before it is caught, because if thrown it to 15, then you catch it at the same velocity, although in the opposite direction. So it will be negative 15 meters per second. C. Then for D, we're asked how long is it in the air? How long is it in the air? Now the total time of flight is twice the time to reach the maximum height. That's what you should understand. Okay, so speed is equals to distance over time. Can this one work? I like starting with the basics. Okay, then if I want to find time will be equals to a distance over speed. Okay, this won't help. V is equals to U plus AT. This is 0, right? Okay, so to make our T the subject to the formula, we're going to say what are we going to have? If I take AT to the other side, it will be negative is equals to U. Then if I want to remain with my T, I'm going to divide by negative acceleration, which will give me so a U over T. But now remember that this thing is thrown upward, so this is supposed to be negative instead of a positive, so it means it will be negative acceleration. Okay, so this will give us, it will still give us a positive. Okay, so we have U over A, and our initial velocity, it was thrown at 15 meters per second, over the acceleration it is 9.8 okay meters per second. We're finding the time. If you made time the subject to the formula, when you divided, T is equals to that. So 15 divided by 9.8, on my end I'm getting 1.53 seconds. So this will be the time it will, just when you throw it upwards. But now after you've thrown it upwards, because we've used 15, right, going up, but now this thing is also coming down, so what will be the total time? So you multiply what you found by 2. So what you are going to have when you multiply, I'm getting 3.06 seconds. So this will be the total time. Okay, how long is it going to be in the air? It has gone up, it is still in the air, and that is about 15 meters per second. You found that it's 1.53. Then again it's going to come down. Okay, so it means you just have to multiply the time that it went up plus the one that is going to come down, so that you find that's why we multiplied by 2. Then the last question is, okay, how long is it in the, determine the sign of the velocity. Determine the sign of the velocity. We've already determined the sign of the velocity. It went up negative 15. It has come down. It went up positive 15, come down negative 15. So you're able to see that this is just a negative sign. Okay, then let's go to the next question. 6, it says the thickest and strongest chamber in the human heart is the left ventricle, responsible during systole for pumping oxygenated blood through the aorta to the rest of the body. Assume aortic blood starts from rest and accelerates at 22.5 meters per square seconds to a peak speed of 1.05 meters per second. How far does the blood travel during this acceleration? How far does the blood travel during this acceleration? Okay, so V squared is equals to U plus 2AS, right? Okay, then if I'm going to make you're saying the thickest and strongest is the left, is pumped through the heart and to rest. Assume that it starts from rest. They've told you it starts from rest. So if it starts from rest, your U is what? Your U is 0. Okay, so your U is 0. So what I'm going to, V squared is equals to 2AS. And if you're going to find how far, which is the distance, you're going to divide by 2A on both sides. Okay, so the distance therefore just be the V squared over the 2a. The v squared you've been given, it accelerates to a peak speed of that. Okay, so it is accelerating at 22 point. Okay, so the v we've been given, it is 1.05. that is the speed. Now this is squared over 2 multiplied by the acceleration. The acceleration we've also been given, it accelerates at 22.5 meters per square seconds. I'll not put the units. Then you solve these two. Okay, so what I'm going to have on my end, when I calculate, I'm finding 0.02439 meters. Okay, so that will be the distance. Okay, so the blood will travel approximately at that distance during that acceleration. Then question B is how much time is required for the blood to reach its peak speed. How much time? We're talking about time. How much time is the blood? So to find the time required for the blood to reach its peak speed, we're going to use v is equals to u plus 80. 80 we said starting from rest, so our u is 0, so v is equals to 80. Okay, our acceleration in this case, what is our acceleration, or how much time is required? So we make t the subject of the formula, so divide by acceleration on both sides. So therefore our t will just be equals to v over a. The velocity, we've been given the velocity is 1.05 meters per second. The acceleration we've been given is 22.5 meters per square seconds. Then you divide the two. When you divide 1.05 divided by 22, on my end I'm getting 0.04667. so this is in seconds. That would be the time. Okay, in seconds. Question 7 is an airplane carrying out parcel drop releases a parcel while traveling at a steady speed of 90 meters per second at an altitude of 200 meters. Calculate the time taken the parcel leaving the airplane and it's striking the ground. The resultant distance traveled by the parcel in this time, the speed at which. So let's say this is an aeroplane. Okay, how do you draw an aeroplane? Okay, now this aeroplane is going in this direction, then as it is traveling it drops a parcel. Okay, it drops a parcel. Then let's say this is our ground. Okay, so the first question is calculate the time taken between the parcel leaving the aeroplane and the aeroplane striking the ground. Okay, so you know that it will be a projectile once it is under the influence of gravity. Okay, so what are we going to do? So to calculate the time taken between the parcel leaving the aeroplane and it striking the ground, which kinematic equation are we going to use for freeform? So what are we going to do? Okay, so let's see which one has time. S is equals to ut plus half at squared. Okay, are we given the distance at an altitude of 200 meters? Okay, u it was like it just dropped, so that would be 0. Okay, I think this one will work. So this it was released, so it's like coming from rest, so our u will be equals to what? 0, right? So s will be equals to I'll not write this because this will give us 0. So half at squared. Then for me to remain with t squared, what am I going to do? Let me first multiply by 2 throughout on both sides. So this will remain, this side I'll have 2s, the 2 and the 2 will go. So I'll have at squared is equals to 2s. Then for me to remain with my t, I'm going to divide by acceleration on both sides. Then for me to remain just with a single t, I'm going to do the square root on both sides so that the square and the root will cancel. So t is equals to the square root of 2s over acceleration. So that's the formula that we are going to use. Now the square root of 2 multiplied by the s, the height we've been given, it is 200 meters. Okay, 200 meters. This one, 200 meters. So multiplied by 200 meters divided by the acceleration. The acceleration, we're told it's traveling at a steady speed of that in an aeroplane. But now, this is a projectile. It is under the influence of gravity. So the acceleration due to gravity, or this is the speed, it's not the acceleration. So the acceleration due to gravity will be 9.81. Okay. Then you solve this. What am I going to have? I'm going to have 6.35. What are we calculating? The time. So that is 6.35 seconds. So that is the time it will take the parcel leaving the airplane to strike the ground. Okay. Then question B, we're supposed to calculate the horizontal distance traveled by the parcel in this time. The horizontal distance. Okay. So you know that this is like the range. You guys have done projectiles. This is like the range. Okay. So the distance in this case, or the range, will just be what you know that we just say is vt. Okay, that will be the range. So the speed we've already been given, it was moving at 90 meters per second, multiplied by the time we've already found, it is 6.35 seconds. Then you find that. Okay, so what are you going to have when you multiply those ones? Is it 571.5 meters? So this is the horizontal distance that will be traveled, the range. This then C is the speed at which the parcel strikes the ground. Okay, the speed at which the parcel strikes the ground. Okay, so what do we do? Which formula is the best? If we say V is equals to U plus AT. Okay, is this going to work? Okay, let's try. So when it is hitting the ground, you know that when a projectile is hitting the ground, let's say this is a projectile, it goes like that, and when it hits the ground, so I find that as it is hitting the ground, it will have the x component and the y component. So it means you have to find the distance both in the x component and in the y component. Now what we have to find the initial horizontal speed and the final vertical speed just before impact. Okay, so for us to first find the vertical one, or the vertical one is this one. So what are we going to have? This same formula. So our u is 0, okay, when it's hitting the ground. Then our acceleration is 9.81 multiplied by the time. The time is 6.35. So when you do that, I'm getting 2.6. So this will be the final velocity when it hits. This will be the velocity when it hits the ground in the vertical axis. So it will be 62.6. This is in the vertical. But now in the horizontal, we've already been given it was traveling at a steady speed of 90 meters per second. So this is 90 meters. So these are the two velocities that we have. Now for us to now find the final velocity, what do? We're going to say the velocity, or the final velocity, will just be equals to the square root of the initial velocity plus the final velocity in both directions, because it's a projectile. Okay, so the v squared in the x and plus the v squared in the y. Okay, so what are we going to have? The square root of, we have 90 squared plus 62.6 squared. Then you solve. So on my end, I'm getting 104.6 meters per second. So that will be the final velocity. Question number 8. The average person passes out an acceleration of 7 grams. Okay, suppose a car is designed to accelerate at this rate. How much time would be required for the car to accelerate from rest to that? Okay, so let's see. V is equals to U plus 80. Okay, and what are we calculating? How much time? We're calculating the time. So let's make t the subject of the formula in this case. So V minus U, right, is equals to 80. Then when divide by acceleration on both sides, so therefore our T will just be equals to V minus U over acceleration. What is our acceleration? What is our velocity? And what is our acceleration? Okay, so let's see what we have. A car accelerates from rest to that. So we've been told it's accelerating from rest to this. So so this is the final velocity, because starting from rest, initial velocity, this one will be 0, right? So let's find the final velocity. Now we've been given 96.6 kilometer per hour. Okay, so it means we have to convert that to meters per second. Okay, so what are we going to do? So you just know that 1 meter is just the same as 1000 kilometers, right? 1 kilometer, actually 1 kilometer is just the same as 1000 meters multiplied by, in 1 hour, how many seconds do we have in 1 hour? So 1 hour has 3600 seconds. Okay, so the kilometers can cancel, the hours can cancel. Then you solve what is on top divided by 3600. So when you solve, I'm getting 26.83 meters per second. So this is the final velocity. Then what other thing do we have? The acceleration. The acceleration we've been told is it passes at an acceleration of 7 times 9.8 meters per second. So we're going to multiply those two. 7 multiplied by 9.8, 7 multiplied by 9.8 meters per square second, that is acceleration. So when I calculate this one, I'm finding 68.6 meters per square second. So that is the acceleration. So let's just replace. The final velocity is 26.83 minus the initial, which is just 0, over acceleration, which is 68.6. Then you divide 26 divided by 68. That will give you your time. So the time in this case is just 0.39 seconds. Okay, so the car would require approximately about 0.39 seconds to accelerate from rest to 96 kilometers per hour of 7 that grams. Okay, then number 9, you are designing an airport for small planes. One kind of airplane that might use this airfield must reach a speed before takeoff of at least 27.8 meters per second and can accelerate at 2 meters per second. If the runway is 150 meters long, can this airplane reach the required speed to take off? If this case, the V is 24. B, if not, what minimum length must the runway have? Okay, so to determine if the plane can reach the ground, or which let's see what we have. The V we've been given 24. What about other things are we given? U, the one kind of energy might use have to reach a speed of at least can accelerate. If can this airplane reach the required speed to take off? Okay, so if we say V squared is equals to U squared plus 2AS. If the runway is 150, can this airplane reach the required speed for take? Can this airplane reach the required speed? Okay. So let's see what we have. V is not actually 24, and then uses must reach a speed before takeoff of at least. So if it's going to reach a speed before it takes off of this 27 point, so this 27 will be our final velocity. Okay, 0.8 meters per second. Then it can accelerate at that point. So the acceleration we've been given is 2 meters per square second. Then the initial velocity, let's assume that this plane is starting from rest, so we're going to say it's 0 meters per square second. Okay, then what other thing? The distance will be, we've been told if the runway is 150 meters long. Okay, so the distance in that case is 150 meters. Okay, so now what do we have? What are we now going to have? So so the V squared, that is 27.8 squared, is equals to U squared, we've said is 0, so just have 2 multiplied by our acceleration. Our acceleration we've been given that it is 2 meters per square second. Okay, this is multiplying by what are we having? Multiplying by our acceleration, which is 2. We've already put that. 2 multiplied by the distance S. So it means we are going to multiply 2 multiplied by 2s, that is just the 4s, right? So we're going to multiply by 4 on both sides, so that we just remain with our distance. We want to find the distance if it's going to be equivalent. So the distance that I'm finding, 27.8 squared divided by 4, I'm getting 193.5 meters. So that is the difference that we are having. That is the distance that we are having. Now, since the calculated distance is greater than the given one, the one that they've given us on the runaway is 150 meters. But for us, we found 193. This is greater, right? So the airplane cannot reach the required speed for takeoff on 150 runaway. Okay, that's what you need to understand. So that's what the question: can this aeroplane reach the required speed for takeoff? No, because it won't. Why? Because the distance that is going to travel is supposed to travel 193, but you have a smaller runaway. So by the time it's supposed to take off, your runaway is already exhausted, so it means it won't take off. So that's what the first question is about. Then the second question B, if not, what minimum length must the runaway have? What minimum length must the runaway have? So to find the minimum length of the runaway required for the to reach the required speed for the, so let's try to what minimum? We've already found it's the same 193 point, because that's the minimum. Otherwise, if we, that's the minimum at 193 meters, 5 meters, that's the minimum that this plane can take off. But if we say, anything less of this, it means it won't take off. So this question is, if not, what minimum length must the runaway have? It's the same one. This will be the minimum. If you increase it, even better. So that will be the minimum. Let's solve the last question. So a paper in the journal Current Biology tells of some jellyfish-like animals that attack their prey by launching stinging cells in one of the animal kingdom's fastest movement. High-speed photography showed the cells were accelerated from rest for 700 nanoseconds at 5.3 times 10 to the power 7 meter. Calculate the maximum speed reached by the cells and the distance traveled during the acceleration. Okay, so high speed shows the cells are okay, good. So what are we now going to have? So to calculate the maximum speed reached by the cells, which now kinematic equation are we going to use? So what do we have? We have at a paper, okay, high speed cells were accelerated from rest, so u is equals to 0 because it started from rest. Okay, for the velocity, the final velocity, you're saying 7, what are we going to have? Rest for 700 nanoseconds. So we've been given the time is equals to 700 nanoseconds. Okay, then what will be our maximum velocity? Then they're saying at 5 point, that is the velocity, so this is the final velocity, 5.3 times 10 to the power 7 meters per square second. Okay, now that is actually the acceleration. Okay, that is the acceleration. So what are we doing to do? We are trying to calculate the maximum speed. Okay, even greater, so even better. So v is equals to u plus at. Our u, we're saying starting from rest, so it's 0, plus at. Our acceleration is 5.3 times 10 to the power 7 multiplied by the time. The time is 700 nanoseconds. 700 nanoseconds, so 700 times nano just means 10 to the power -9. Then this is seconds. Okay, so this will be the expression that you're supposed to solve. So when you solve, your v is going to be 3.71 times 10 to the power 4 meters per second. Okay, so there, that's the maximum speed which should be reached by these cells. Okay, so now B is saying the distance traveled during the acceleration. The distance traveled during the acceleration. So I always start with this one. S is equals to ut plus half at squared. Now we know that our initial is 0 because it started from rest. So I'm just going to get half multiplied by the acceleration. The acceleration we said is 5.3 times 10 to the power 7 multiplied by the time. The time we're saying it's 700 nanoseconds. Okay, 700 nanoseconds. So that's the same as 700 times 10 to the power negative 9. But now this, don't forget to square it because t is squared. Then you solve this whole expression. Okay, so on my end, I'm getting 1.295 times 10 to the power negative 9. This is distance, so it's in meters. Okay, so this is how you solve tutorial sheet 2, or for others it's tutorial sheet 3, physics 1015. Thank you, see you in the next session.